Hey guys, what's up? How's it all going? Yes, we're back on the channel again. And in its English version itself, now I had to go silent on this channel due to some issue currently ongoing. Many of you might even be knowing it. Now we are heading back to our business. And yes, now we will be making this channel again active. So now as we are back, I welcome you all to our own channel, Deep Coding. Notice as we are now back in the game. Today we will be making something really hot topic right now. And that's a machine learning model. Which will predict the origin of the wine from its chemical analysis. We will import the dataset, see about how a pandas data frame works, how a NumPy array works, how matplotlib works, and then plot a pie chart to visualize the data, and then we will be making the model. So, without wasting much time, let's begin. Okay, now what I want you guys to do is head to your Google Chrome or any browser, whichever you want. Now, some people have Edge their favorite, some people have anything. You can go to anywhere. Right over here, you see a machine learning repository. And then go on this link archive.ics.uci.edu. Well, what I will be doing is I will be pinning this link in the description from where you can get directly to the page to download the dataset. Okay. So over here we have this homepage. I want you guys here we have this dataset such as Iris. Iris is the most basic and most popular dataset for machine learning, which mostly all of the you say all of the beginners learn and work upon it. Okay, and then we have this all other data sets. Now where I want you guys to go is go into this view data sets. Go over here, you have this wine. Not this wine quality, you have this wine with 178 instances, and that's where I want you guys to head off on. Head over here. What we'll be doing is we'll be using the chemical analysis to determine the origin of wine. Then you have this additional information over here. These are the data of the results of a chemical analysis of wines growing in the same region of Italy, but derived from 3 different cultivars. And originally this data set had actually 30 values, but now this person has taken only 13. So as to limit this data set. Okay, different attributes given are over all of this. Okay, we have this flavonoids and 5% in color intensity, hue, proline, malic acid, etc., etc. And we will be doing this classification. Okay, I will show you. This is not very challenging as this guy is itself saying. It's easy, and I will tell you each and everything. We will do each and everything. Then we have this class, which is actually the integer. It's actually an integer. It's 1, 2, 3, showing the origin because they have 3 origins, right? From 3 different cultivars. So it's the class or the cultivar you can say it accurately. Okay. Then you have this all other builds we have. Let me increase this to 15, and so I can show you each and every variable name. So we have all these variables over here, which we will be targeting to. Okay. This is actually called as these other, except this class. These all others are actually told as actually regarded as targets. Targets is the sense, feature. Features in the sense it's something which will help us to add to our target. Okay. So this is what we will be doing. We will be predicting this class of the wine. Okay. I have made a file. I have actually tried this before making this video. I will show you how we have done it, what I have done. Then I will make a fresh file in front of you, starting from 0. Starting from a blank file, and I will tell you each and every step what I want you guys to do and follow. Okay, so just follow this video. We will be making a complete. We will be doing this. We will be doing this completely from the beginning, from the point 0, where I will be teaching you guys. Okay. Next is you have to go to the top again. See over there you have 3 buttons: download, import in Python, and cite. I want you guys to click on import in Python. First, you have to install this UCI ML repo, this package. What other thing is you can download this. You can use it as a data. As a pandas data frame directly. I will show you how you can access it, but better is for now use this import in Python, and then click this install from UCI ML repo, and then copy this complete code from the UCI ML this web page. Okay, perfect. Now I want you guys to head to the VS Code itself. Okay, let's don't save this. I have this file made already. Let me show you. I have imported this dataset completely. Then I have imported other modules which I will be needing over here. Then I will show you this data set starting. Okay, then we are visualizing the data how much wines and how much cultivars have how much instances. Okay, then we are making machine learning model. I will teach you to even write markdown code as a heading. Okay, so all in all, this is all random. I will tell you, we will do each and everything. Let me tell you, we will do it from point 0, and then we will be doing this. Okay, so now I want you guys to click over this new file over here. Give whichever name you want to give. I'm writing over tutorial for wine. Dot. Now this extension is important. IPYNB. Don't use .py. I want to use a Jupyter notebook over here. Why Jupyter notebook? Because once you run a cell, these are all the blocks. See over here. I'm adding all. See, these are all blocks. Once you run this single cell, it will assign the variable itself into a terminal. So this variable has been already assigned a value. It will already assign a memory which will not be changed easily. Each time you run a .py file, let me just copy this file and make a duplicate it. Over here, see, let me add a .py over here. So each and every time you determine a variable over here, each and every time you determine over here a variable, and then you run this file. So what it will do is, it has a grid of memory. It will assign a new point, a new space in the memory again and again as you run. Okay, but in Jupyter, what's the advantage is that it has to assign the variable only once in a memory, and then it can access it again and again. So that's the you can say advantage of Jupyter. Okay, so that's why I want to use Jupyter over here for now. Yes, you can use .py as well. Okay, but it won't change code much. Jupyter is also some shortcut that I want you guys to know. To delete a cell, generally you have to press D key 2 times. This D 2 times, and it will delete the cell. Okay, see, the cell has been deleted. It has been deleted. Okay, so that's it. When you want to add a cell, you have to press a B, assuming that the cursor is not in the cell. If the cursor is inside the cell, press escape, then press B. You have a new cell, then press enter to type inside the cell. Perfect. So and then press B to insert a new cell, then press D key twice, and you can delete the cell. Perfect. Now what I want other thing to do is you have to install this Jupyter extension in the VS4 itself. Okay, you can and other thing I want you guys to do is add it to your terminal. Open up a terminal window. As you open this terminal window, it will pip install Jupyter. I want you guys to do this. Pip install Jupyter. You have to install the Jupyter module over here. I have already installed, so I'm just terminating this. Okay, so I have already installed it down here. Okay, let me show you itself now. So sorry, Control C, pip install Jupyter. There's upgrade if there's any. Okay, even you can install Spider in this way. So Spider is another IDE that you can use for Python itself, but it usually utilizes .i extension. Okay, see, I have already installed this over here. Okay, it's already requirement is already satisfied. So Jupyter is already installed. Next, we are doing is pip install UCIML repo. This is also installed in my device. Okay, it is also installed in my machine. And now what I want you guys to do is type here Jupyter notebook. Yes, then there is the sound of rain over here. Okay, so here Jupyter notebook is being opened. I don't want it in the browser. Okay, even you can close the browser itself. Now I want you guys to see over here this link, Jupyter server 2.14.0 is running at over here. Copy this link, and I want you guys to first of all okay, just give me a minute. Okay, maybe I have this in my clipboard itself. See over here, I have this UCIML repo import, and this data, this complete code I want you guys to copy and paste over here. Now run this. It will tell you here over here we have this kernel. Now kernel is actually something that is being connected. Wait, just give me a minute. Why is it going back for me? Why is it going back for me? Kernel is basically something, it's a port from which you are connecting to a Python interpreter. That's nothing else. So go over here, then select another kernel. You have this. You may not have this option by default. You can see this over here. You click on existing Jupyter server. Click and then it's saying enter the URL. So wait. So we have this URL over here which I copied from here. See this? It's running over here. I can show you and then paste it. Enter, and it will run. Now select the kernel. You can select this, and yes, it's done. Why did I do it this way? Because I just want the things to be easy for my machine itself. I don't want this to search and make a port and do all the things. I want this thing ready by itself. Okay. So let's interrupt this. Okay, bye. Cool. Now unless this thing figures itself out, let's enter a new cell. Now I want to change. Actually, I want to add a markdown. So I want to add here a comment. Markdown. You have to add one hashtag so as to make this as a heading. Importing. Wait, let's turn on the caps lock. Importing the modules needed. And then press Ctrl and Enter to run the cell. Okay. Now type here import numpy as np. Import matplotlib dot pyplot stlt. Import pandas. Pandas is actually not needed, but okay. spd. We may need. I am not sure. If it is not, we will delete this line. Now over here the other lines what we'll be doing is it's for the model. Okay, from sklearn dot models dot linear model import logistic regression. Okay, from sklearn dot what other thing we have to import, dot model selection, we have to import train test rate, and another import what I want is cross val score. We have to import cross val score. These 5 things will work. Another thing which you guys may need is from sklearn. We are not using it over here because it's not needed. Dot linear, no, not this. From sklearn dot pre-processing, import label encoder. Okay, so we have the thing, but we are not using this, so I'm commenting it out. Another thing what I want is we will sometimes okay, let me just show you first. I will show you something and then we will do it solution. Let's close this. Let's delete this by permanently. We don't need it. Okay, so why is it working or what's it's doing? Wait, let me just close this file and turn it on again and click on run on. It will connect for the to the kernel. Okay, yes, and let's see what is it doing. If it runs now, so it will show you the time it lasts for running this. Okay, see over here it's time, it's showing some time. Another thing what I want you guys to do is this X is a capital X. I want to turn it to the smaller one so as to make it easier for us to follow nothing else. Okay, yes. Come on. See over here, you guys can see, and there is a tick mark, so that means that the scan has been done successfully. Now I want this cell to run also. I don't know what's wrong in this. Okay, wait. Control X, remove this cell, and now you press over here B, and then you have this insert it. Okay. See now over here, you have these 2 buttons. Not add a code, add a code set or add a markdown. I want a markdown over here. Importing the data set. Okay, run this and it will make a heading. Okay, so now the dataset has been imported. Let's use this. Let's keep this open so it becomes easier for me to see, or else it just moves too much to the left. Right. Okay. See over here, we have this dataset has been imported. All this it's all this metadata, and this is all this variables that we are facing it. Okay, I actually don't want to go much deep into this, so I will be commenting it out. And yes, I want the output to be clear. Now another thing what we have is over here. See, this is wine.features. That's all this we have seen. That alcohol, malic acid, and all that Q and all. Okay, and this target is what we are actually we will be predicting the cultivar of the wine itself. Okay, now let's enter a new cell. Okay, see, press escape, press B, and then you have a new cell. Okay, over here you can change some code to mark. See over here, you have this Python. Click here, then you can change this to markdown itself. But I don't want this thing now to work. I don't want. Okay, so we have imported the modules. Okay, so let's jump into it. Now I want you guys to see what's in this dataset. Now Python is actually a good thing. Normally when you are using a .py file, you have to write it in this way in order to print something into the console. Right? In order to get this into the console, you have to print it this way. But Python has a shortcut. You just have to tell it that you have to show this, and it will do it by itself. Okay. So what Jupyter usually does is, if you have something that has a variable, see now let's say this is a variable string. Okay, then you go to end and write 8. So it will do this, but now it will not print the one before. So it will just print the last one that is being that the variable is being declared. So over here you don't have to write print 8. It will show the same output. Okay, but at least you have this easiness. At least you have this advantage that you have to just write it this way. Okay, so I have done this x.head, but now what I want is to do is print this. Okay, and now I want to print a \n, print a new line, and then print y.head. Okay, what are this x and y? See over here, this is features and target, and both are written as pandas data frames. Okay, so because I am using a print function over here, it has converted completely into a string and then showed it to us. Okay, but if I just write this y.read over here, it will it will show me a table. See over here. Okay, so even if I write just y, it will show a table to me. See over here, we have 1, 2, 3 complete. Okay, so this is all just I wanted to show. Okay, and this cell's work is now over. And now let's run this cells all completely once again. Perfect. Now I want here to click there, plus escape, press enter a new cell. Okay, now I want to change this to markdown. And now what we'll be doing is visualizing the data. Okay, now we are visualizing the data. Okay, now I want to enter a new cell. We have this Python set over here. Now what I want is I want this this class thing to be printed as a pie chart, to be shown to me as a pie chart. So now let's first you guys don't need to convert it. Let's take this np.array y array, you can tell it like this, or even you can use y.to_numpy, and that's it. Both ways will return a numpy array. Okay, right? So both ways you guys can do this. See over here, you have this, and even you can let me show you y array, and it will return the same output. Okay, let me comment this so that you guys cannot just put a finger on me. Okay, so it's the same thing. Okay, so but doing this way, it will be easier for you to do this, because I want to reshape it into 1, -1. Let me tell you what does this do. Okay, so reshape, first thing is the columns, and the second thing is the rows. Okay, so it just give me a minute. I just need to interpret it once. It can do this. Wait. 1, -1. Okay, so what does this thing do is it actually changes this complete array into a 1D array. Okay, it changes this array into a 1D array, but this array may not be able to fit properly, because so that's why we will be using y.to_numpy and not this. Okay, so let's write y_array is this, and it's giving me over here. Perfect. Now I want this thing to do is, let's see what this thing interprets at all. For a in y_arr, if a is double equals to 1, it's all of these are integers, then n1 plus equals to 1. Okay, so now I will be declaring 3 variables, n1, n2, n3. Let's see if this thing works this way. Okay, it does work. This reshape is actually not needed. We will do this way. If a is double equals to 2, then n2 plus equals to 1. If a is double equals to 3, then n3 plus equals to 1. Okay, now I want this thing to print. Let's copy and paste. Run. Okay, cannot. Yes, so that's what I was thinking actually. Let's see if I just want to try it if it can work in one line. Okay, so so what you guys have to do is you have to match the number of outcomes. These are all saved as outcomes to the number of variables that you are assigning to. So if there are 3 variables, then you have to say give it 3 values. Okay, and that way it will work. That way it will work perfectly. Okay, so why have I converted this to an array? It was because I want to iterate over this function, iterate over this array and get the values. So it has given me 59 times there is the class number 1, 71 times there is the class number 2, and 48 times there is class number 3. So now I will be converting this into np.array, and I will be giving this as a pi array variable. I will be giving this name as a pi array variable. Okay, let's run this. Okay, see now array there is an error coming. So now what you guys have to do is make this as a in a square brackets. Okay, now let me show you this pi_array. So it has made an array out of this. Perfect. So why have I done this? Let me show you something. PLT.py. Whenever you are plotting any matplotlib graph, say it a pie chart, say it a histogram, say it just a normal line graph, say it a scatter chart, anything, you have to first give it a .py function. You have to first give it a numpy array. This thing is important for matplotlib always. Okay, so now I will be giving this pi_arr. Okay, and let me show you the outcome. It will not show an outcome. Actually, it will show because there is Jupyter notebook, but you are always to write this Jupyter plt.show always. Okay, and hit enter. You have this graph. Okay, now it's just looking so much blank. It doesn't have much interesting things to see. So now what I want is you have to write. It takes a argument labels. Make a blank list. Write it as give it an f string. Add over here 1 comma curly braces number 1, and then copy this 3 times. Okay, I have you can do many things like me. I will show you each and everything. Okay, so and 3 and 3. Okay, so see Over here, I have the instances of 1, and that is the coming of 59 times. Okay, this is what we have just seen all over here. Okay, print pi underscore. So this is all what we will be seeing. Another thing what you guys can do is, wait, let me just copy this line, Control C, head to the home, Control V, and commenting this thing out. Alternatively, what you guys can do is range 1, 4, and see you guys have also this classes number 1, classes number 2, classes number 3. Also, you guys can have explode. I will tell you. See over here, all this this is a complete circle that is joined and made together. Okay. Now I want this. Now I want this thing to explode. Right over here, 0.1, 0.1, 0.1, and this thing will move away by 0.1 percentage. Okay. So this is all what we this is our explode thing. Also, I want is a start. Is done anything? Start angle. Yes. Start angle is something. See, the first angle taken from here is taken from here. Now I want this. Now I want this in the start from 90 degrees. So I'm running this. See, now it is starting from the from 90 degrees. Now say if I want to start it from, let's say, 45 degrees. So it will start from 45 degrees and so on. Okay. So these are all some arguments. Now I don't want the start angle to work. Actually, I just want this thing to explode itself. So I'm commenting this out, and I want this original one explode equal to this one. Okay, I haven't picked 2 commas. Sorry. Yes. So perfectly working. So this is what we have visualized the data. Now the last thing what we have to do is to make the model for what we all are over here. So let's make this a markdown cell. And let's make this the final model. Run this and enter a new cell. We have a code. We have the code cell entered over here. Okay, so it's perfectly working what we are doing. And now let's head to the bottom. Let's now give it this a train test split. So X a train, X a test, Y train, Y test. All these are new variables. What we will be doing is giving it a train test split with the two data frames X and Y, and we will be giving it a test size of 0.3. That means 30% of the data set will be split and given out. Will be split and it will be taken as a text size. So it will be assigned to X test and Y test. Okay. So now let's open a model. That's logistic regression. Now I want to add here over here max ether. Max ether to be added as 10,000. So that's why there will be no error being given over here. By default it has 100. See over here, by default it has 100. But I want here to maximum time iterate over itself. Maximum time iterate over its algorithm for 10,000 times. Okay. Now we have model.fit X train, Y train, and then we have a model.score X underscore test, Y underscore test. Okay. Over here, Y that. Okay. Perfect. See, now this is let me show you something. This is a warning coming over here. Right. So this is a warning coming over here. So that's what I was saying, that we have to import one more module that I want over here. Okay. For warnings. Import warnings. Okay. And I want warnings, not filter warnings. And I want it to ignore. Okay. So it will just this warning line will be removed now. See. Oh wait, I have to run this because I told you, right? So it has not taken it into its memory. Now let's just restart this kernel once. So there's reassignment of all the variables. Okay. Let's see. Just wait for a minute. Okay. One. Okay, the kernel has been restarted. Now let's run all these cells and let's head to the bottom. Okay. See now over here, each and every time I run this cell, each and every time I get a different accuracy score. See, 98. This is 94. This is again 94, 96, 90. So each and every time I'm getting a different score. Okay. So it's this 94.4. I don't want this thing to print. So now what I will be doing is adding a print statement. Now open a single quote. Okay. Open a single quote. Right over here, percentage 0.2f. So it will go till 2 floats. Then add a percentage sign before this variable, and then you have this to print. See. Okay. So it's now perfectly accurate. Okay. But now it is now 0.94. So why are we expecting this different values to come? It was just and only because we this train test split actually takes a random values. It actually takes random random iterations or random amount of data set from the original one for the splitting. So now what we'll be doing is we will be giving a random state. What does this random state do is it gives a certain value to the data set to the bring this function such that the data set will remain the same on multiple running of the same. So I will give it a random number, let's say 42. You can even give it a 22. It has also a 30. So it has its many values. I'm giving it a 42 for now. And see over here that is 1. I'm giving it a 22. It has 94. Now I'm running it again. It is giving 94. So how many times you run this? It will give you the same output by defining this random state argument. Okay. So that is it. The model has been completely worked. We have this score. Now I want us to print a cross evaluation score. So CRSCR, I'm giving it a variable. It's cross val score. Cross val score is stands for cross validation score. Then you have to give it the model, that's this logistic regression. Then you have to give it an X value, X test, on which we are testing it, Y test, and you have to give it a CV. CV means the number of times this thing will iterate over itself. Now let's just print the CR under first. Let's print this. It will return an array with multiple cross val scores. Okay, see over here, you can see each and every time it will show the same output because we have defined the random state. Let's remove this random state. Let's remove this. See over here, the accuracy score has been changed as well as the CR score has also changed. Okay, see, this thing is usually used for k nearest neighbors, but we can use it over anywhere else. Okay, so each and every time this gives a new value. Okay, so I'm keeping this random state over here. Now what I want is we have the CRSCR as an array. Okay, we have the CRSCR perfectly working as an array. Now I want plt.plot. I want to plot a graph. First being a range from 1 to 5. 1 to 6. Because the 6 will be excluded. And then we have the CR underscore SCR as the array. Okay. And then we have the plt.grid because I want a grid also to be shown. And plt.show. Okay, so it will show the model score and see over here that is 1, 1, and then you have the 0.8 something below 0.825, and then over here there's something between 0.9 and 0.925, and then again 1. Okay, because this random state has been defined. The values will never change. But if I remove this, see over here, it will show each and every time this is one graph. If I run this again, see it will show me another graph. So this is all what the work of the random state. This is what the random state equals to 42. Let's say 42. 42 is actually giving me a high amount of accuracy. So that's the difference. So you can take any random number over here. Okay, so because I tried to find this on the Google, I tried to find on the internet, but I couldn't get the any peculiarity for this number. So maybe these are just random numbers that you are adding in so that to get the maximum accuracy. So you can also, what you guys can do is, you can also make a for loop for this itself, starting from 22 till let's say 50 or 42, whatever you want to go, and then plot this graph again. Okay, let's try it out. Let's let's just duplicate this cell. Is duplicate. No, let's just copy this. Control A, Control C, Control V. Okay. So now what we will be doing is we shall be removing this. Okay. For I in range 22 to 43, because I want 42 to be included, we will remove this. We will copy this, paste it over here. Random state equals I. Control S. Let's comment this out. Let's copy Control X, Control V. And also now I will be making a blank list for saying scores equals a blank list, and now scores.append model.scores. Wait, I will be adding this string itself. Control C and Control V. Perfect. Let's run this. See, it's now working for 22 till 43. It will print all this and then we assign it itself. But we will be stopping this because we don't need to. Okay. Now what I will be doing is add your scores. Okay. And give this a range of 22 till 43. 22 till 43. I don't want the string to print. I want the string to plot a graph for me. Very good. Something is not okay. Okay, now it's all fine. Good. Okay, so it will take its own time because each and every time it will be running this and it will be splitting it. It will be appending the score and it will go. See over here. You have the maximum accuracy. See, in this way, you are starting from 22. It's working from 94, then going to 93. So this is all what we are expecting to for guys. Okay. So that's it. Wait, just give me a minute. Okay, so that's it for today. Hope you enjoyed the video. Hope you learned something new. And till the next video, bye bye. Take care. All the very best.